So sometimes they want us to verify inverses, or they want to give us two functions and say, hey, are these inverses, yes or no? So it goes back to that concept. If you take a function and you compose it with the other function, you have to just get x out of that. Now that can also be written f of g of x like this, but you have to get x. Not only does it have to work that way, it has to work the other way as well. So when you're verifying inverses, or you're checking to see if two functions are inverses, you have to do both. You have to do two compositions. Okay, so here's our example. Show that each function is the inverse of the other. Now, whenever they say show, that means we already know the answer. We already know they're inverses, so that we just are proving that they're inverses. We're showing that they're inverses. So what we're going to do is we're going to do the composition. We're going to go f compose g of x. And we can write this f of g of x like this, if you like that better. But we're doing this composition, and in the end, we're supposed to wind up with just x, right? Okay, so we kind of already know the answer. So it gives us a chance to practice composition, though. We're going to take this expression, g of x, and we're going to put it right there. So this is going to equal 3 times x minus 2 over 3 plus 2. That's the composition right there. I'm taking g of x, and I'm plugging it in for f of x. Okay, now here comes some algebra. The 3's cancel, so those are out. Now I just have x minus 2. You can put parentheses if you want, but they're not necessary. And then the negative 2 and the positive 2 cancel out, and we just get x. Okay, so that part works. F of g of x gives us x. Okay, we're halfway done. Now we have to go the other way. And we have to say g of f of x. And you use a little circle too, but now we're going to take f of x and we're going to put it in right there. So it's going to look different. I'm going to have 3x plus 2 minus 2 over 3, and it looks like that. Okay, I don't need the parentheses in the numerator. So the 2's are canceling out. Now I have 3x over 3. The 3's are canceling out, and I just get x. So we can just put a smiley face here or something. We've shown that it works, okay? So when we did f compose g of x, we get x. And when we do g compose f of x, we get x, okay? So that's what we do to verify inverses. And sometimes, you know, they could give us two functions and say, hey, we don't know if they're inverses or not. Can you see if they are? Well, then you run the same test.